All right, Math 3, we are going to start multiplying and dividing radical expressions. We're going to be dealing more with what we did the other day. If you want to go through here and take a look, they're just giving you some examples of what you can do here. Like if you have your exponents are the same, you can go ahead and multiply the base numbers together and then square it. So you can take 4 times 5 and then cube it, or you can do them individually and do it. And the same is true with your index. If these are both squareds, you can multiply what's underneath. These are both cubes, so you can multiply underneath. All right, and that's kind of what it's saying right here. So when I come down here, they ask if you can simplify this. No, you cannot simplify this one because you have an index of 4 and an index of 5. You cannot put those together because your indexes are different. But here you have indexes of 5, so you may go ahead and you multiply your radicands, which is going to give you to the 10th power, or the 10th. So that is fine. Up here, if you take a look, they both are cubes, so you're going to take the cube root. You're going to do that, which is 64. Well, the cube root of 64 is 4, so 4 is your finished answer. Here, you can do it. Yeah, you can have 3, 18 times 12. I don't know. Anyway, the answer comes out to be a 6. When you multiply a negative times a negative, you're going to get a positive underneath here. And so I'm guessing it is 216. When you do that, you get an answer of 6. Okay, down here, we're going to be breaking down some radicals. They kind of explain it through here, how you can do it. This is just one way to do it. I don't believe we did some of these when you were in Math 1, and I don't really explain it this way, but you can sure look through here. Everybody has their own techniques and how to do it. What I do when I'm looking through here, I try to find the perfect cube that goes into this. If it's not perfect its own self, and it's not. So what I like to do is to find a perfect cube that goes into it. Well, that would be 64. All right, so I'm going to break down the 128 into the cube root of 64 times the cube root of 2. All right, I'm going to worry about my x's here in a minute. So I'm breaking this 28 just down into 64 times 2, and the reason I chose 64 is because it is a perfect cube. Well, the cube root of 64 is 4. So I have this 4 out here, and I have the cube root of 2 left underneath. Then I'm going to worry about these x's. Well, how many times does 3 go into 7 evenly? You divide it in. Well, it goes in there twice, so I'm going to get x squared out here. And I have 1 remaining, and that remaining 1 stays underneath. So there are my finished answers. And I don't have to worry about any absolute values because that was to the 3rd power. So that is your finished answer. All right, so here you're going to do the same thing. Find a perfect cube that goes into 81. All right, well, 27 is its perfect cube. So you're going to break 81 into 27 times 3. Well, the cube root of 87 is 3. And then you're left with that cube root of 3 here. All right, well, 3 goes into 3 once, and there is no remaining. So there's your finished answer. All right, let's come over here. I got to find, this one's our 4th roots. All right, well, 4th root would be probably 16. I believe it's 16 times 4, all right? So 16 is a perfect 4th root times 4. So you're going to break 64 into 4th root of 16, which is 2. And then you do the 4th root of 4. So 16 times 4 is at 64. So 4th root of that is 2. I'm left with the 4th root of 4. All right, now I'm going to look at my numbers. Well, 4 doesn't go into the 3, so it just stays as x to the 3rd underneath. How many times does 4 go into 6? It goes in there 1 time, so I'm going to put 1 out here, and then I have 2 remaining, and the 2 remaining go underneath. Now, I will need absolute values here because this is an even power and this is an odd power, so I need the absolute values there. You'll never put absolute values under your thing. So there is your finished answer for that. All right, what you're going to do here, a couple of different things. You can either multiply these together and then break them down, or you can break them down individually and then multiply them together. So it really doesn't matter. It's entirely up to you. Sometimes it's easier to do while they're smaller numbers instead of combining them to do it. So I'm going to break down each of these individually, and then we may need to again at the end. So the 45 is really going to break down into, these are square roots. The square root of 9 times the square root of 5. 35 does not break down into anything. All right, so I think what I am going to do with this though is, it's not a perfect number, but I'm going to break the 35 into 5 times 7. I'll show you here why I'm doing that in a minute. All right, so right here, these are just the 45 and the 35. All right, so when I put all of this stuff together, well, the square root of 9 is 3. All right, so that took care of that. The square root of 5 times the square root of 5 is the square root of 25, which is 5. So that took care of those. And I'm left with that square root of 7 that can't go down any further. All right, so what I have right now out here is 15. All right, and then I'm going to have the square root of 7. I'm going to now put my x's together, so that's really x to the 6, because there's a 1 and a 5. Here is going to be y to the 7th. And we need to go through and now break this down. So the 15 again will stay. Here's your 2. 2 goes into 6 3 times. No remaining. 2 goes into 7 3 times. With 1 y remaining, and that 1 y that remains is underneath. Now both of these are to the well, I guess they're not going to worry about it in here, I don't think. Yeah, it's right here. Well, I guess really you should have those in absolute values, but I guess since they're not going to worry about that anymore with this. So there's your finished answer right there. All right, so let's go over here. I don't know. On this one, I think I am going to multiply them out. The only reason I didn't multiply this because 45 times 35 is a pretty big number. All right, so I'm going to go ahead and multiply this. So I'm going to take this -1 times this 2. Then I'm going to do the cube root. 2 times 15 is 30. X to the 7th power because you're adding the 2 and the 5. Y to the 3rd power because you're adding the 2 and the 1. All right, so you're trying to find a perfect cube that goes into 30, and there is not any. So that -2 is going to remain, and that cube root of 30 is going to remain. All right, there's no perfect cube in there. All right, well, 3 goes into 7 2 times, so that x squared comes out. You have 1 remaining. 3 goes into 3 1 time, so I have 1 y that comes out and none remaining. So there is my finished answer. All right, over here, again, I think I'm okay to multiply these back out. So the 3 is on the outside, 3 times 1. Then you're going to do the 4th root. 18 times 6 is 108. A to the 10th, b squared. All right, so now what I'm going to do is see if there's any perfect 4th root. Okay, your 4th roots are like 16, 81, I think it's 625. This is 2 to the 4th power. Oh, I need 3 to the 4th. That's 3 to the 4th power. 4 to the 4th power is in here somewhere. This is 5 to the 4th power. Okay, so we're missing one in here. But anyway, it doesn't go in. So the 108 does not break down. So the 3 stays out. The 4th root of 108 will stay underneath. Now I'm dealing with my variables. 4 goes into 10 twice, so I put 2 out here. There are 2 remaining. 4 doesn't go into 2, so the b squared has to remain underneath. And there is your finished answer. All right, so that was multiplication. Now on division, kind of the same thing. It tells you if you have the same index, you can divide them, things like that. You can write them down here as separate, or you can write them as 1. All right, so when I come over here, what they're saying is it is okay for me to write this under one big radical if I want to. All right, and by doing so, I can go ahead and simplify down now. Well, 2 goes into 50 25 times. Okay, on the division, I'm going to subtract my exponents. So x to the 6th minus x to the 4th is an x squared. Well, if I have that, we just did this on the last lesson, the square root of 25 is 5, and you're going to have a squared on here, and 2 goes into 2 1 time. So you get 5 to the x power.